M1 Statics Example 1. In this example, we have a diagram here representing some forces, and we have an x-axis and a y-axis. It says that this particle is in equilibrium. Now, in equilibrium, that means that the forces horizontally and the forces vertically have a resultant of 0. So in other words, forces to the right-hand side would balance with forces to the left-hand side. Forces upwards would equal forces downwards. So if we resolve the forces here and show that we're resolving in a particular direction, so to the right hand side, because I'm turning through the angle, it's P cos 30 to the right, and nothing else has a component to the right, and then to the left we've got 4 cos 45. So by resolving horizontally we can work out the magnitude of the force P. It will be 4 cos 45 divided by cos of 30, and if you work that out on your calculator we get 3.27 to 3 significant figures. However, I'll just say at this point keep the full value in the memory of your calculator because we're going to need it in a second. So that's horizontally. If I now resolve vertically, again because it's in equilibrium, forces upwards will balance with forces downwards. So these two forces, 4 and P, both have an upward component. So we have 4 sine 45. Remember, we're going away from the angle. But we also have upwards P sine of 30. So there's two components upwards, and that is equal to Q downwards. Now we can do all of this all in one go on our calculator. We know the value of P, it's in the memory of our calculator, so don't use the rounded value, use the one that you've saved in the memory that's got all the decimal places. And if you do that, you should get your value of Q to be 4.46. It should have been putting units on, so I'll quickly sneak those in. They're forces, so they're in newtons.